A Starship Gigafactory is being built by SpaceX to revolutionize rocket production, boost efficiency, and mass-produce rockets at an unheard-of rate. The Starship and Super Heavy will be mass-produced in this first-of-its-kind operation at a rate that the aerospace industry has never before even dared to imagine. Gwynne Shotwell, president of SpaceX, has already established the audacious objective of producing one rocket per day to do this. You all must be thinking that, what are the objectives behind this project of SpaceX of building a Starship Gigafactory? How much time it will take to complete? What would the SpaceX Starship equivalent of a Tesla Gigafactory? The answers to all these questions are in today's video. But before starting the video, if you are new to our channel and haven't subscribed yet, then do subscribe to our channel and press the bell icon so you will never miss an update in the future. Let's dive into the video. Similar to the method pioneered at Tesla over the past 3 years with their Gigafactories, SpaceX will need to use very effective advanced production techniques. As a result, we anticipate a significant crossover between the two. It appears that the goal is to construct one Starship rocket per day, which is an extremely ambitious and unimaginable goal. Even Elon Musk's prediction that Tesla would produce 1 million electric vehicles annually would have received the same criticism 10 years ago. As of right now, the business has accomplished all of that and more. It will likely produce 2 million cars this year alone. And this isn't even just Elon Musk talking. Although we are aware of his propensity for outlandish statements, Gwynne Shotwell, the president of SpaceX, is renowned for her pragmatic outlook and capacity to secure multi-billion-dollar deals. Earlier last year, Shotwell, a government contractor, reportedly asked reporters, "Why can't we build a rocket every day?" This is what Starship is focused on, tackling every step of the manufacturing process so that we can produce a large number of these machines. Language like this is simply never used by the CEO of any legacy aerospace business. Just for now, let's attempt to gain perspective. The Space Launch System developed by NASA is the closest rocket to Starship in comparison. The SLS design calls for parts from Boeing, Northrop Grumman, Lockheed Martin, and Aerojet Rocketry, all of which are produced in various locations around the United States before being transported across the nation and put together in Florida. The SLS can only produce one rocket per year at a maximum cost of $4 billion for each launch, but SpaceX is now asserting that they are capable of producing a bigger, better rocket every day of the week. Elon frequently discusses at Tesla the distinction between creating a prototype and mass-producing a finished product. Like, how could it ever be conceivable when compared to how absurdly challenging it is to manufacture that product at scale? The process of designing and creating prototypes is rather simple. Consider the cyber vehicle as the ideal illustration. 4 years ago, Tesla created the first Cybertruck. They are still trying to find out how to bring the product and all of its parts to a point where they can mass produce them efficiently for a reasonable price and in large quantities. SpaceX is currently in a very similar situation with the Starship, of which they have already produced numerous prototypes. Before they even had the chance to explode one Starship and an extremely heavy stack, the majority of them had either exploded or been scrapped and recycled, even made a heroic attempt to reach space, but sadly and predictably it also detonated. This is beneficial. Iterative design is what this is. Each Starship or Super Heavy booster is either an experiment or an evolution. No two have ever been created identically. With each fireball, SpaceX comes a little bit closer to understanding how Starship wants to be constructed. Maximum manufacturing flexibility is required throughout this stage of the development process. Because of this, SpaceX continues to assemble their Starships by hand, for the most part, working primarily outside in open spaces where anybody may observe. Considering that methods used today will differ from those used tomorrow, at any time, they must be able to clean the slate. Due to this, SpaceX has only recently started construction on their first actual Starship factory and production line. Soon, space travel on board a Starship will be limited to trips that can be completed safely and dependably. The Starship design will then be deemed ready for mass manufacturing at that point. we can examine the building procedure that SpaceX has thus far employed to gain a sense of what will transpire inside a Starship factory. At Starbase, SpaceX has built several vertical assembly structures, including the giant bay, the high bay, the mid bay, and the low bay. Even though a second mega bay is already being built, the low bay was only recently destroyed. These structures are utilized to assemble the rocket stages by stacking prefabricated ring parts and welding them together, which is a clear indication that progress is being made. According to Elon Musk, the reason SpaceX has maintained enlarging these structures over time is to add more workstations to each bay. The procedure of constructing rockets within ships and boosters can be done simultaneously while building more ships and boosters. As time passes, these bays have grown significantly more automated. Robotic arms have taken the place of human hand welding, and SpaceX has started installing enormous turntable machinery that enables them to spin the rocket as work is being done. Thus, moving from one side of the rocket to the other requires neither a person nor a machine. Simply said, the rotation will bring the distant side to them, so you may imagine these tall structures as general assembly locations. In the early stages of Starbase, SpaceX personnel worked out of 3 long tents that served as their main production lines, while the more sophisticated manufacturing took place in the lower sections. While fabrication work is being done in a few smaller outlying tents. These tents will all eventually be replaced as the permanent factory building grows. Even the 3 iconic major production tents that have stood the test of time at Starbase since the beginning are presently being removed from the location as manufacturing shifts to the Star Factory. Making rockets in tents may come across as a joke, but Tesla learned to create the Model 3 and Model Y by learning to make them without trying to fit them into the factory area they already had. In the parking area, Tesla erected enormous tents and began to reconstruct the system from scratch. In this way, they were able to incorporate cutting-edge production methods like their Gigapress casting machine. These are just too large to simply put into a factory floor that already exists. Tesla then began utilizing their first Gigapress to make cars at Fremont beneath a tent. Once they were certain that it served their needs, they could construct their new Gigafactories so that the Gigapress machines would be at the center of each one. Large rolls of stainless steel 304L are sent to SpaceX as raw materials, and these rolls are later cut to length, molded into rings, and welded. The curved parts like the nose cone and the interior domes that serve as the tops and bottoms of fuel tanks become the boosters and ship's straight sides. SpaceX receives stainless steel panels that have been stretched and pressed, which they then solder together. The top, middle, and bottom sections of the Starship are fundamentally produced in each of the 3 primary tents. For the lowest thrust part of the ship and booster, one tent is equipped with Raptor engines. The ring sections and domes that make up the Starship's body and fuel tanks are housed in the center tent. Between 3 and 5 steel rings are welded together to form each piece. Because the tent is so small, it is typical to merely do this outside in the open air when sleeving the ring parts over the top of the domes. Then, a variety of cuts are applied to each portion to prepare it for its particular regulation. Water systems and reinforcements, thermal insulation, and heat shield tiles are also installed here in the tent on completed ship sections for the higher stage. The further production of nose cones takes place in the 3rd tent. These are constructed from extended stretch-form sections of stainless steel that are joined together along vertical lines using welding. This procedure enables SpaceX to produce the essential parts of the spacecraft and booster at the same time on the ground before bringing them all together at the mid bay for final assembly. The nose portion is also equipped with its heat shield before rolling out. After being piled together, the parts receive finishing touches like wings and actuators. In the past few months, the Starfax factory has started to take shape. As the first phase of the Star Factory came to an end, SpaceX started laying the groundwork for a permanent structure to be built in line with their 3 main tents. At the same time, work was already being done to clear the area directly behind the tent row by tearing down their low bay and propulsion facility. The inside edge of the production area will now serve as the basis for Star Factory Phase 2, which will extend to the main road. We're currently considering a sort of L-shaped structure with a roofline that is 60 feet tall and the longest edge that is roughly 800 feet long for the Star Factory building. Having one continuous factory floor rather than 3 distinct tents will, of course, simplify the manufacturing process and give SpaceX 2 to 3 times as much covered floor space. Hope you liked the video. Don't forget to give this video a thumbs up and share it.